There's a lot more to the skeletal system than just the skeleton itself. Today we're going to investigate the anatomy and physiology of the skeletal system. Hi everyone, welcome to the Physical Educator. Today we're going to talk about the skeletal system. We're going to start off by getting straight into the objectives. As you can see from the assessment objectives on the right hand side, there's 4 objective 1, the rest are objective 2, there's no objective 3. What this means is there's not going to be any explanations needed for the skeletal system, there's not much depth that you need to go into, but there's a lot of breadth to cover. Therefore, we need to cover the wide range of keywords, and the way these keywords are spelt is what we need to explore for your understanding. So, first up is the distinction between axial and appendicular skeleton with regards to the location of the bones. When we break the skeleton up into axial and appendicular skeleton, we can start with how the words are spelt. Axial means axis, so it's its central point, it's what it rotates around, and that's your axial skeleton. So you can see the bones within the axial skeleton, and they're all very central to the middle of the body. As we move on to the appendicular skeleton, and the word append means to attach, to support, so it attaches at the shoulder and the hip. I'm not going to go through all of the bones in the appendicular skeleton with you, but I want to draw your attention to just a few. The radius and the ulna. The easy way for you to remember these is the thumb bone being the radius and the little finger bone being the ulna. Don't learn them as the outside and inside bone. As you can see with this diagram, one hand is facing in and one hand is facing out. So if you use the idea of the ulna being on the outside and radius on the inside, then you've got 2 different bones because of the way the arm is rotated. Look closely at the skeleton's right elbow. You can see the radius and the ulna rotating, and we'll look at that with joints later on. And that's what happens with your forearm, as you know, when you rotate in and out. So your ulna is on the little finger side, usually on the outside, but it depends if you rotate. And your radius is your thumb side. The easiest way for you to remember these bones is to separate them by axial skeleton, upper body and lower body in the appendicular skeleton. And as you can see with the different colours on the screen now, there's your 2 sections to learn within the appendicular skeleton. And there's one simple method here: repeat, repeat, repeat. It's the only way this information is going to transfer into your long-term memory. Lastly, we're going to look at the names in the vertebrae. We've got different sections. We've got the cervical section of the vertebrae with 7 bones in, thoracic with 12. Easy way to remember that, it's attached to your ribs. You've got 12 ribs. Each thoracic vertebrae is attached to a rib. And then your lumbar vertebrae at the bottom with 5. They're the 3 sections of your vertebrae. You also have your sacrum and your coccyx underneath, forming your tailbone. So, some tips here when remembering the vertebrae. Cervical, swervical. So that's at the top of your neck, that's when you swerve your neck from side to side. Thoracic, Jurassic, so it's inside a cage like the dinosaurs are, and that's your rib cage, the thoracic chamber in the middle. And then lumbar, strong like a lumberjack, because if you look at your vertebrae, the bones get bigger as they go down, and that's because your lumbar vertebrae at the bottom is carrying the most weight above it. Therefore, these simple tips will enable you to remember the order of cervical, thoracic and lumbar. Up next is the functions of the skeletal system, both within the axial and appendicular skeleton. There are many functions within the skeletal system, protection being one of them. Something we're familiar with, the axial skeleton protects vital organs, the rib cage protects the heart and lungs, it does that in sport from a kick or a ball hitting the chest. Also, the cranium protects the brain. Again, we know that protects from a punch. It might be a header in football, whatever it may be, but it's an obvious one. Axial skeleton protects vital organs. One that's not so obvious is that our appendicular skeleton also protects organs, and it protects reproductive organs. Have a look at this free kick. Brian McBride in the wall with his armband on as captain has his hands over his area. Now he's protecting himself. He's using his appendicular skeleton to protect his reproductive organs. This could be exactly the same in a basketball match set in a screen, or in a football match, as you can see here, extending your arms over your reproductive organs. This could be the same for a female, as her arm could go across her chest as well as between her legs. Another function of the skeletal system is red blood cell production. Now again, this takes place in both long and flat bones, and we'll come to it shortly with its blood supply and the red bone marrow and how it produces red blood cells. We'll come to that later on in the topic. But for now, a function of the skeletal system is red blood cell production. We also have shape and support. Now, shape and support are two different things. Shape, your skeleton allows us to hold the position that we're in, whether that's sat down, standing up, doing a cartwheel, doing a gymnastic pose, striking a position before you kick a football, a little bit like Robin van Persie. That position is held by our skeleton. It gives us the shape to be able to do so. Support is a little bit different, and we've already spoken about the lumbar vertebrae being slightly bigger towards the bottom of the spine because it's holding up more weight above it. And this is exactly the same here with support. Let's take some other examples, not just the vertebrae. Look at your tibia bone compared to your radius bone, both in the lower extremity of that limb, but the tibia is much bigger and much thicker. This is because it carries so much more weight above it. Another example, the femur in the thigh and the humerus in the upper arm. Again, both in the upper extremity of that limb. However, the femur is much bigger bone than the humerus, again because it's carrying more weight above it. Therefore, there's more pressure on it. Therefore, it needs to be a bigger bone for support. We also have mineral storage within our bones. Now, calcium and phosphorus are two minerals that are stored within bones until they are needed. Calcium obviously for bone strength as well as other functions. Calcium is very key for the sliding filament theory when you look at Unit 4. You've also got phosphorus, which is stored until it's needed in the rejuvenation of ATP and also nerve activity. So calcium and phosphorus are stored within our skeleton. And lastly, the most obvious function you can think of, muscle attachment. Bones are attached to skeletal muscle via tendons. Long bones act as levers and they allow us to create movement based on the relationship with muscles and tendons. Thirdly, we're going to look at stating the different types of bone. 4 types of bone. We're going to start with flat bones. Flat bones technically are also a type of joint, because a flat bone such as the cranium is small bones fused together to create that bigger surface area. Same in your ribs, same in your pelvis, same in your sternum. Now the reason for this is twofold. Firstly, it creates a bigger surface area for protection. So the ribs, the pelvis and the cranium, a bigger surface area to protect what is within them, or for the pelvis to protect what's above it as it holds up the organs. It acts as a bowl. Secondly, because it's got a bigger surface area, it's also a bigger surface area for muscle attachment. Therefore, it can be a major area for muscles to attach to, such as again in the pelvis where you've got the link between your legs and your upper body. We also have long bones. Now, long bones are categorized as bones longer than they are wide. They're used as levers to allow limb movement. Many examples in the body: tibia, humerus, femur, clavicle are just a few. Phalanges are also categorized as long bones in the hands and feet, and there's many long bones in the body. Probably the most obvious one out of the 4 that we learn. We also have short bones. Now, short bones are cubed bones, and you'll see this further when we look at joints. And tarsals and carpals are example of short bones. Many short bones, cube bones, that glide together to create the very unique movement that we have at our wrists and ankles. And finally, we have irregular bones. Now, irregular bones don't fit into any other category. They look irregular. They're different shapes and sizes. And the examples, when you see the examples, you understand exactly why. Vertebrae, all different shapes and sizes. Coccyx, 4 fused bones at the bottom of your spine, along with your sacrum, and then your mandible, which is your jawbone. Very unique bones, very different looking bones. Even the vertebrae coccyx and sacrum, the bones that are within that group of bone, if you like, even them are all different. So it's very, very, very irregular with the type of bone. 1.1.4, draw and annotate the structure of the long bone. So I've not seen many draw questions here, but you may be asked to draw it, you may be asked to annotate it. Either way, what's important from this is that we learn the basics. Now, firstly, when you're describing the locations within the long bone, these are the key words to remember: epiphysis and diaphysis. Now, you've also got metaphysis, which sits in between them. But let's keep it simple. Let's go with epiphysis and diaphysis. And if you look at the prefix of this word, epi means end, and dia means passing through. So you shouldn't get them mixed up really. Epi is at the end of the bone, either end, and diaphysis is the middle of the bone, where the compact bone is. Now what we need to learn is what's on the inside of these bones. So if we look at the inside of the bone, inside the end of the bone, there is some spongy bone. And within that spongy bone, there is red bone marrow. Now, the red bone marrow is essential for red blood cell production, and that's in the ends of the epiphysis. In the compact bone, which is within the shaft, within the diaphysis itself, we have a couple of things here to remember. A medullary cavity, again, cavity meaning hole, medullary, med meaning middle. So it's a hole in the middle of the bone. Nice, easy way to remember that. Within the medullary cavity is your yellow bone marrow, which is fat storage. Around your marrow and your medullary cavity and around the compact bone is the periosteum, which is the outer layer of the bone. Two additional things to remember here. Articular cartilage sits at the end of the bone, and that prevents rubbing with other bones. And you also have a blood vessel that runs through the bone, as each bone requires its own blood supply. So to briefly summarise, we need to have a blood vessel, we need to have a medullary cavity. Within the medullary cavity, we need yellow bone marrow. Around the compact bone in the diaphysis, we need a periosteum. At the end of the bone, spongy bone with red bone marrow and an articular cartilage right at the end. Next, we need to explore the anatomical locations of bones within our body. Anatomical locations, some of them by the words seem very obvious, some don't. And we're going to start with an obvious one. If you are superior to somebody in life, you are above them. If something is superior, it is above it. And it's no different when describing a location of a bone in the body. If it's superior, it's above something. So the femur is superior to the tibia. Inferior is underneath. So again, the fibula is inferior to the pelvis, and it's underneath that bone. We also have lateral and medial, terms that you're probably familiar with and you've heard a lot. Lateral means towards the outside. Medial, med, the word med, the origin of that word means the middle. So the medial is towards the middle, lateral is towards the outside. Ligaments are a great example here. You have your lateral ligament in your knee, you have your medial ligament in your knee on the inside. And I'll briefly revisit this when we look at the knee joint shortly. Proximal and distal, two words that you won't have heard of before, but again, look at how they are spelt. We've all heard of the word proximity, close proximity, and that's what you need to remember here with proximal. It's close to the joint, so it's the proximal aspect to the joint. Distal, further a distance away, therefore distal is further away from the joint. So if you're talking about a muscle attachment to the distal end of the humerus, it's towards the elbow. If you're looking at a muscle attachment to the proximal end of the humerus, then you're looking at the attachment towards the humerus right where the deltoid area is, right where the shoulder is. We also have anterior and posterior. Now, anterior means to the front, posterior means to the back. So the sternum is anterior to the vertebrae. So you got these 8 words to remember, and there's sort of like 4 ranges. Goes from anterior to posterior, proximal to distal, lateral to medial, and superior to inferior. And you need to know these words in a description. It could be a simple question of what is anterior to the vertebrae, and you've got to provide an answer. It could be as simple as that. It could be a picture and you've got to describe it, whatever it may be. But as long as you understand them 8 key words, you won't go far wrong with this section. Up next, we need to look at what holds everything together within the skeletal system, our connective tissue. 3 types of connective tissue that we need to look at. Firstly, cartilage. Now, cartilage acts as a shock absorber and prevents friction where the bones articulate. So firstly, the word articulate is just a nice posh word for where bones join together. That's all that means. So articulating cartilage is cartilage at the end of the bone where they meet together. And again, it prevents friction. You've also got cartilage in between joints. Think about your vertebrae. In between each of them 34 bones, there is a layer of cartilage, and this acts as a shock absorber, hence the suspension picture on your screen. Now, if you take out that suspension, if you take out that cartilage, and you were to jump up as high as you can and land on your feet, think about all them bones crashing together. It would be a lot of shock and a lot of pain going through your vertebrae, same in your knee. So cartilage is in there to absorb that shock of that landing, and also to prevent friction of the many times your joint moves throughout the day. Cartilage can run out. We develop osteoarthritis as we get older. Not everybody does, but it's a condition that can develop because your cartilage is worn away over time. Also have tendons. Now, tendons attach muscle to bone. And when a muscle contracts, it changes length. And that's what I want you to consider here. The muscle contracts and changes length. And attached at the end of the muscle is a tendon. And the tendon runs across the joint and attaches to your bone. When your muscle contracts, it shortens and it brings and pulls that bone across the joint in. Take the bicep as an example. The bicep contracts. The tendon runs across the elbow into the radius and ulna. As the bicep shortens, the radius and ulna get pulled up, just like the drawbridge example on your screen. And that is how movement occurs. Finally, we have ligaments. Now, ligaments, they hold bone to bone and they do not assist with movement. Ligaments secure articulating bones to make a stable joint and to make you stable as a person. So when a muscle contracts, movement can take place at the elbow joint or the knee joint because the ligaments are holding that joint together. So they do work hand in hand, ligaments and tendons. They have different roles, but they do effectively work together. Ligaments prevent movement in certain directions. So we know a hinge joint in the knee only has flexion and extension, and that's because of the setup of the ligaments, and it only allows them specific ranges of movement at the joint. So it restricts movements into other situations. That's why when you see people who get injured when they overstretch, it's because of the strain on the ligaments and their job to keep them in check. (1.1.7) Define the term joint. Nice and simple. A joint is where 2 or more bones articulate to form a joint. Now, this word articulate, I've mentioned it already a few times. It simply just means where bones meet. Next one, and I'll say this a few times, different types of joint. Not synovial joint, different types of joint. Really important with this section that you know the difference between types of joint and types of synovial joint, because you can easily miss marks on an exam here by simply misreading the question. If your question asks for types of joints, this is what it's talking about. 3 types of joints. If it's asking about types of synovial joint, then that's later on in the video that you need to speak of them. So let's stick with 3 types of joints. Firstly, we have fibrous joints. Now, we mentioned flat bones before, like the cranium. They are held together in a fibrous joint, and these joints allow no movement whatsoever. So the cranium is an example, so are the ribs, so are the pelvis, so is the sternum. Examples of fibrous joints within the body. Absolutely no movement takes place. Our second type of joint is cartilaginous. Now, this type of joint exists within the vertebrae. There is little movement. So there is some movement in our vertebrae. We're not stuck like an ironing board when we're upright. There is some movement, but they're not as freely movable as our synovial joints. And there's 6 different types of synovial joints that we need to look at, and these are classed as freely movable joints. Next, we need to look at common characteristics of synovial joints. So, synovial joints all have things in common. They all have common characteristics. Now I'm going to use the knee joint as an example so you can see these characteristics. So within the knee joint, we have the patella, which is the kneecap. Underneath the patella, we have the patellar tendon. Now this tendon attaches the quadricep to the patella as well as to the tibia. We have the femur, the thigh bone, we have the tibia, and we also have the fibula. At the end of each of them bones, we have articular cartilage to prevent friction. Now, within the knee joint, we have meniscus, and this meniscus allows the bones to slot together like a jigsaw. And then we also have ligaments that keep the joint stable and only allow specific movements. Now, other characteristics, we have bursa. Now, a bursa, as you can see on your diagram, is this blue area on the left-hand side. Bursa are little sacs that sit beneath the muscle and the tendon, and they prevent friction. Sometimes you may have been injured and you've been to a physio before, and you think you might have been injured before, and you know it's your ligaments, or you might have a muscle strain. You go and you think you know what you said to the physio, and the physio says, no, all your ligaments are fine, your muscle's okay. It's actually your bursa that's inflamed, and it's pushing on your nerve, it's pushing on your pain receptor. And bursa's in there. Now, a functioning bursa, you don't feel any pain from, because it just provides a little bit of extra support in between the muscle and the tendon. Within the joint, you can see a joint capsule, which is this, they look like purple brackets on that diagram either side of the bone, and that holds everything together. Think of a capsule, think of a paracetamol capsule. It holds all of the contents of the paracetamol inside it. Your joint capsule does exactly the same thing. Within it, you have a synovial membrane. Now think of science, cell membrane. It's the outer layer of the cell, isn't it? It's exactly the same here. So come inside that purple joint capsule, and that very fine black line that's inside it, that is your synovial membrane on the outer layer of the inside of the joint capsule. Now, the synovial membrane secretes synovial fluid, which is like our natural WD-40 that lubricates our joint and allows us to continually move our bones without causing too much friction, which would obviously cause pain and osteoarthritis again down the line with overuse. We want to try and avoid that if possible. These are the features that are common to a joint, and I've used the knee as the example. Obviously the bones are different, but everything else that's been mentioned is the same. Tendons, ligaments, bursa, synovial cavity, synovial fluid, synovial membrane, joint capsule, and articular cartilage. These features are common in all 6 synovial joints. And finally, list the different types of synovial joints within our body. Synovial joints, we're going to start with the obvious ones. We'll start with hinge. Now, a hinge joint is what's known as uniaxial. That means it goes through one plane of motion, one axis of rotation, and it allows flexion and extension to take place at the knee and at the elbow. We also have a ball and socket joint. This is a triaxial joint, meaning it can go through all 3 planes of motion, all 3 axes of rotation, and it allows a wide range of movement, flexion to extension, abduction to adduction, circumduction and rotation. The examples are your hip and your shoulder. Now, it looks like this is the super synovial joint. Wow, look at all the movement that's available, it's triaxial. Yes, fantastic, but because of the extra range of movement available, it's also more susceptible to injury than the others. Hence, the hip and shoulder dislocations are more common than dislocating any of your other synovial joints. We also have gliding joints. Now, we spoke of this earlier when we spoke of carpals and tarsals and short bones, how the short bones, cube bones that glide together over each other. Inside the red circle, you can see a collection of short bones, and they are what make up the gliding joint. And they glide over each other and provide an up, down, left to right movement of our wrist and our ankle. We also have a saddle joint. Now, a saddle joint is your thumb. Up, down, left, right, biaxial, similar to gliding joint with regards to the movement, but it's your thumb, and it separates us from everything else in the animal kingdom. We have this. And the reason it's called a saddle joint, it genuinely looks like a saddle that's on the back of a horse. That's how it is. It's concave, and that's how it looks. And that's our saddle joint, which is our thumb. We also have a pivot joint. Now, two examples of pivot joints. We have the atlas and the axis, which is what you can see here at the top of the vertebrae, creating the neck, which creates rotation in your neck, allowing you to look left and right, a little bit of up and down, but also your radio-ulnar joint. Now, remember at the start of this video when I spoke about your thumb facing out or your thumb facing in, and that movement that you can do in your forearm is your radio-ulnar joint rotating, and that's what gives the impression that the radius might be on the inside of the arm instead of the outside of the arm, because they rotate over each other within the radio-ulnar joint. And finally, we've got condyloid joint. Now, a condyloid joint is also biaxial. It allows flexion, extension, abduction, adduction. The examples within the body here are the metacarpophalangeal joint. And you're probably looking at it thinking, what's that talking about? But break it down. A lot of things in science, if you just take a second to assess how it's written, you can get your answer. And here is a perfect example of that. Metacarpals meet the phalanges. And as you can see on the diagram, you can see where the metacarpals meet the phalanges because it looks different. It looks like a burger bun right in the middle of the screen. And that is the joint that we're talking about here. The other example is where the radius meets the carpal. So where your radius bone meets the collection of carpal bones that sit within the wrist. Two examples of condyloid joints. For teaching resources on the musculoskeletal system, you can visit the TES channel for the physical educator, where you can pick up resources for the skeletal system as well as muscular system. Good luck with your studies. See you again soon.